I'd like to welcome you to today's webinar. Today we will discuss Fronius storage solutions. And this also forms part of our storage solutions month for November. So again, please make sure that you do also watch the next two webinars on this topic as well. Okay, to introduce your team for today, I am Mohammed Sidat, the Technical Sales Advisor for Southern Africa. I operate from Fronius South Africa, which is an agency of Fronius International. I'll also like to introduce my colleague, David Mwangi, who is the Technical Sales Advisor for Eastern Africa, and he operates from Fronius International. To cover today's agenda, we're going to start with an introduction to our inverter range. We'll then move on to solutions for maximum independence, have a look at overview of solutions, battery compatibilities. We will then move on to and discuss our different hybrid inverters, starting off with the Symo hybrid. We will then move on to the Fronius Ohmpilot, after which I'll hand over to my colleague David, who will then discuss the Gen 24 Plus inverter series. He will also have a look at the BYD Premium HV battery, also AC coupling solution, as well as how can you visualize this data on SolarWeb. And we will then end with a 5-minute Q&A session at the end. So again, please make sure that you do stay to the end. Inverter range. So Fronius has been active in the field of PV electronics for quite a while now. And in 1995, we introduced our first series of inverters called the Fronius Sunrise inverters. There is still some Fronius Sunrise inverters that are still operating on the field to this day. And again, just reiterates the quality that you do get from Fronius. We then came out with the second generation of the IG series. Okay, these are all grid-tied inverters. We then introduced the Snap inverter series from 2013 onwards, okay, of which was our very popular range, okay. And we also, within that range, we also introduced the Symo hybrid, which was the hybrid inverter from Fronius. Again, with our Snap inverters, you can also take them and make them a hybrid system or off-grid system using an inverter charger. As of this year, we did introduce the Fronius Symo Gen 24 Plus hybrid inverter, which is a 3-phase inverter, hybrid inverter. We will also be introducing our single-phase Gen 24 Plus inverter next year. Okay, next year we will also be launching the Fronius Taro, which is the 50 kilowatt or 100 kilowatts commercial 3-phase inverter. Just to give you an overview of the different hybrid inverters from Fronius. Starting off with the Fronius Symo hybrid. This inverter is still in production and will still be in production for many more years to come. It comes in 3 size variants, 3 kilowatts, 4 kilowatts, or 5 kilowatts. It is a 3-phase inverter. It allows for direct battery connection, and it has a single MPPT tracker, and it also allows for 3-phase full backup power. Then introducing the Gen 24 inverter series, which is our new range of hybrid inverters. With the Primo Gen 24 Plus, we've got a 3 kilowatts to 6 kilowatt power variants. Okay, they are single-phase inverters. They allow for a direct battery connection, and it has 2 MPPT trackers. It also allows for single-phase backup power, okay, which will allow the full backup power of the inverter. And we also have a special feature for PV Point, which allows backup power without batteries, as long as you have PV irradiation, PV power being produced. Then moving on to the Fronius Symo Gen 24 Plus inverter. This is a 3-phase inverter, which comes in these following power variants, 6, 8, or 10 kilowatts. It allows for direct battery connection, and it has 2 MPPT trackers. It allows for full 3-phase backup power. Okay, And it also has a special PV point feature, which provides an emergency output of 3 kilowatts max, as long as you have enough PV power being produced. Moving over to the next topic, we will discuss the solutions for maximum independence. So further elaborating on the previous slides, to do with the Gen 24 Plus inverter range, we have the Primo and the Symo. Okay, the first difference is the Primo is a single phase inverter. Primo stands for primary, which in our case will mean single phase, and Symo stands for simultaneous, which in our case will mean 3-phase. So that's always a quick and easy way to distinguish, a Primo versus a Symo, whether they're single phase or 3-phase. Okay, the Primo will also come in these power classes. So any one of those power classes you can purchase the inverter in. And the Symo will come in a 6, 8, or 10 kilowatt power class. They will both have 2 MPPT trackers. They both have an IP66 protection. So you can basically install this inverter outside, okay, which is a really big advantage. The dimensions of the Primo and Symo Gen 24 Plus is really market leading, and this for an inverter that has 2 MPPT trackers, can do battery charging, and that can also supply the AC load at the same time, all in such a compact size is really market leading. The weight for the Primo Gen 24 Plus will be 16.6 kilograms, and the weight for the Symo Gen 24 Plus will be 24 kilograms. In terms of the input voltage range, the Primo Gen 24 Plus will start producing AC power as long as 65 volts on the DC is reached, whereas with the Symo, as long as we reach 80 volts DC. The maximum voltage you can attach to the Gen 24 Plus per string is 600 volts, whereas with the Symo Gen 24 Plus, it's 1000 volts. Okay, both of these devices have basic grid backup integrated. Also, the Gen 24 Plus has already won multiple awards in the industry. The most notable award was the Intersolar Award. Okay, and this award is awarded to the best solar inverter each year. And in 2020, the Fronius Gen 24 inverter won this award. Again, it's actually the most prized award in the PV industry, and for our inverter to actually win this award, really states a lot. Okay, the inverter has also won other awards, such as the Energy Storage Inspection. This award was carried out at a university in Berlin, and the Fronius Gen 24 Symo with the BYD battery actually proved to be the most efficient system compared to its competitors. The Gen 24 Plus has also won the Plus X Award, and it has also won the Red Dot Award for 2019. Moving on to the Fronius Symo hybrid inverter. This is a 3-phase inverter. It comes in the following power classes, so 3, 4, 5 kilowatts. It has a single tracker. Degree of protection is IP65. Its dimensions is slightly bigger than the Gen 24 Plus, and its weight is around about 19.9 kilograms. And it also has a dynamic peak manager integrated, which is also found in our Gen 24 Plus range. Our Fronius Ohmpilot is also another option that can be integrated to improve your self-consumption. The Ohmpilot provides actually another alternative to batteries, or we can actually work alongside with batteries to improve your self-consumption. Okay, the Ohmpilot comes as a single device that can be either wired as single phase or 3-phase. It can give it takes a maximum input current of 16 amps on the single phase, or on the 3-phase, 3 times 16 amps. Input voltage 230 volts for single phase and 400 volts for 3-phase. Maximum output power for single phase, it will be 3 kilowatts, and for 3-phase will be 9 kilowatts. Okay, again, you can also have a read through the other stats, but we will further elaborate on the Ohmpilot a bit later on in today's presentation. The Ohmpilot also won an award. It won the German Design Award, special for 2019. And again, just the Ohmpilot is basically a device that allows a homeowner to heat water, okay, in order to store any excess solar energy that is produced throughout the day. What's very important with any Fronius storage solution, okay, that I did present in the earlier slides, is that you have to use a Fronius smart meter. Okay, the reason for this is the Fronius smart meter is there in order to detect, where the energy is coming to or from the grid, and it also detects the consumption, the inverter production, and it can also control the energy flows in the system. So we can control, how much energy is going to the battery, how much energy is going to the grid, etc. In terms of the smart meters from Fronius that you can purchase, we have 3 smart meters that are currently on the market. The first one is the 100 amp single phase smart meter. These are targeted for residential systems, and it can take an AC cable cross section of between 1 to 16 millimeters square. We also have the 65 amp 3-phase smart meter, which is again for residential systems, and it can take AC cable cross sections of between 1 to 16 millimeters square. We also have the big 3-phase smart meter, which is the 5 kiloamp smart meter. With the smart meter, you have to use external CTs, and you can use any external CT as long as they have a secondary current of 5 amps. Moving on to an overview of the different solutions offered by Fronius. Starting off with a DC coupled battery storage system with thermal storage system and grid backup function. Okay, so this is system 1 and system 2 indicated over here. With system 1, which is the Gen 24 Plus, with the Ohmpilot, with a Fronius smart meter, and with battery storage. Okay, so what is the applicable battery storage solution for such a system? It should either be the BYD battery box premium HVS or HVM. Okay. This also allows for a thermal storage solution to be incorporated. In our case, it is the Ohmpilot. It also allows for grid backup functionality integrated as well. And the degree of self-sufficiency is very high. Okay, so with such a system, you can actually ensure that your client can easily achieve a 90% plus self-consumption efficiency rate. Okay, moving on to the second system, which is the Fronius Symo hybrid inverter, incorporated with an Ohmpilot, a smart meter, and some battery storage as well. What is the applicable battery storage solution for such a system? It would be the BYD battery box HV, which stands for high voltage, the BYD battery box premium HVM. Okay, so those are the 2 applicable BYD batteries. Okay, we also have the LG Chem Res-U, which is also compatible with the Fronius Symo hybrid inverter. Okay, with this solution, it also allows for a thermal storage component to it, which will be the Ohmpilot. It also allows for a grid backup function only when you use the BYD battery and not when you use the LG Chem Res-U battery. The degree of self-sufficiency is very high in such a system. Okay, moving on to system 3. In such a system, we have the Gen 24 Plus with the Fronius smart meter and with a battery storage element. Okay, for such a storage solution, we can use the BYD battery box premium HVS or HVM. There is no thermal storage component to this solution. It does allow for grid backup functionality, and the degree of self-sufficiency is high. Okay, moving on to the 4th solution, which is the Fronius Symo hybrid with a smart meter and with a DC battery. Okay, such a system is compatible with the BYD battery box HV or the BYD battery box premium HVM or even the LG Chem Res-U. There is no thermal storage solution for the 4th system because we don't have an Ohmpilot installed, and we do offer a grid backup functionality on only when the BYD is installed with the Symo hybrid. Degree of self-sufficiency again is very high. Well, not very high, but just high. Okay, remember the difference when you have an Ohmpilot installed is that you can achieve a 90% plus self-sufficiency and consumption rate. Whereas if you do not have the Ohmpilot installed in a hybrid system with a battery, you will have slightly less degree of self-sufficiency. Okay, moving on to the next type of system is that you can have a Fronius snap inverter, okay, incorporated with a smart meter and with a PV string battery storage solution. Okay, so a classical example of a company that produces a PV string battery storage solution is SolarWatt. Okay, and basically what a battery storage solution is that your PV panels will produce a DC DC power, which then gets sent directly to a battery, which stores this power, and this battery will then send the power to the Fronius inverter. Okay, depending on how much energy is needed by the load. Okay. Okay, with such a system, you cannot install a thermal storage solution. Okay, it does not offer any grid backup functionality. So when the grid goes down, this PV string backup, this PV string battery will also go down. Degree of self-sufficiency is high. We then have another solution, which is called the AC coupled battery storage system. Okay, in such a system, you basically take a Fronius inverter. So in the first case, we had the Fronius Gen 24 Plus. Okay, we then couple it together with an AC grid-tied inverter, which could be a snap inverter. Okay, and we then incorporate it with a smart meter. With such a system, we can incorporate a battery storage solution. Okay, we can also have a grid backup functionality under certain conditions, which we'll discuss later on. And we can also achieve a grid self-sufficiency rate of high. Moving on to the next type of system, which is a thermal storage system. So in such a system, we do not have any batteries installed at all. We only have the Ohmpilot together with a Fronius inverter and a smart meter. Okay, so in such a system, we do have thermal storage solution, yes. Battery storage solution, no. Grid backup function under certain conditions, which we'll discuss later on. And the degree of self-sufficiency for such a system is medium. Then presenting the final solution, which is a storage system ready with hybrid inverters. Okay, so in this case, we just have a Symo hybrid with a smart meter, or we have a Gen 24 Plus with a smart meter. Okay, just remember, in such a system, the Gen 24 Plus, when it's only installed with a smart meter, can offer you backup power on the PV point without any batteries. Okay, as long as you have enough PV being produced. So with the Gen 24 Plus range, we can offer 3 kilowatts of emergency backup power without batteries installed, as long as there is power being produced by your PV panels. Now moving on to the next section, which discusses battery compatibility. Okay, just to note, with a DC coupled storage system, basically how it works is we have a Fronius hybrid inverter. Okay, in this case, it is the Fronius Gen 24 Plus inverter. Okay, but it could also be the Fronius Symo hybrid inverter. Okay, we also have the Fronius smart meter, which has to be installed in a DC coupled storage solution with Fronius. Okay, so this is compulsory, and this will communicate with our hybrid inverter over Modbus RTU. Okay, you will then also have the utility prepaid meter before the grid as well. Okay, in between the Fronius hybrid inverter and the Fronius smart meter, you'll then have your AC loads. Our Fronius hybrid inverter can then communicate over Modbus RTU with the battery storage. And as I alluded to earlier on, we can also offer the PV points as well on the inverter. So which batteries are compatible with which DC coupled storage solution? So with the Symo hybrid, these are the batteries that are compatible. It is the BYD battery box, okay? And these are the power variants that it is compatible with. Okay, so it is a high voltage battery. Okay, the Symo hybrid is also compatible with the BYD battery box premium HVM. Okay, and these are the compatible power levels. Okay, it is also compatible with the LG Chem residue as well. Okay, the Primo Gen 24 Plus is going to be compatible with the BYD battery box HVS, so with those two power variants. Yeah, the 5.1 and 7.7 HVS, and also with the HVM. So the HVM 11 stands for 11 kilowatt hours, going right up to 19.3 kilowatt hours. Again, please remember that you can parallel 3 BYD battery box towers next to each other. Okay, then moving on to the Symo Gen 24 Plus, it is compatible with the BYD battery box premium HVS. So it is compatible with the 5.1, 7.7, and 10.2 kilowatt hour battery towers. It is also compatible with the HVM 11, going right up to the HVM 22.1. Okay, currently the maximum amount of BYD battery towers that you can parallel to each other is 19.3. So in total, if you take 19.3 and multiply it by 3, that gives you around about 58 kilowatt hours of maximum battery storage that you can achieve with the Symo Gen 24 Plus inverter. Okay, remember the main advantage of the BYD battery box premium HVS or HVM compared to the LG Chem is that with the BYD, it is mounted on the floor. Okay, whereas the advantage with the LG Chem is that you can wall mount it. Okay. Now moving on to PV string coupled systems. So basically what happens with the PV string coupled system is that you do have a PV generator, which will be your PV modules. They send power directly to the module string coupled storage system. Okay, this system is composed of a battery and a BMS system. Okay, the battery will store all the power it collects from the PV generator, and it will then send power to the Fronius inverter as required. So let's say the Fronius inverter detects that the loads maybe require 3 kilowatts of power or 4 kilowatts of power. It will then send a signal to the our module string coupled storage system and tell it to please send the inverter 3 kilowatts of DC power so that it can convert it to AC. Okay, and basically in the system we also have the solar watt AC sensor, which also communicates directly with the module based storage system. And this in turn will also communicate with our Fronius smart meter, which will again measure all the energy flows in the system. And in between the Fronius smart meter and the Fronius inverter will then have the AC loads. So the main advantage of a PV string coupled system is that you can actually achieve module based storage. Okay, so in this case you can, in the case that your irradiation levels change throughout the day, you are more protected against a change in irradiation levels throughout the day. Okay, so with the PV string coupled system, our Fronius inverters, so most notably the Fronius Primo, the Fronius Galvo, and the Fronius Symo are tested to work with the solar watts. Okay, so the solar watts is the PV string coupled DC storage system. And these are the different variants from the solar watt company that they do produce. So the solar watt system, it is a strand coupled storage system. So we have different capacity levels available. It's basically like a based on a modular approach. You can just increase the amount of modules to increase your DC storage. The storage sizes vary from 2.4 kilowatt hours to 12 kilowatt hours, but you can also go up to 60 kilowatt hours. Again, due to these size variants, this is mainly going to be a target for a single phase markets. Okay. What I have indicated over here is just a reference site. We have a Fronius inverter. As you can see, it's directly attached to the solar watt. Okay. The solar watt system is directly attached then to our modules. So our modules feed DC power to the solar watt system, which will then store all the DC power, and it will then send DC power to the Fronius inverter as needed. Okay, so in this case, we can also achieve a much better efficiency rate, and this also leads to less throttling down of the inverter as well. Now moving on to the Fronius Symo hybrid inverter. As I alluded to earlier on, it comes in a 3, 4, or 5 kilowatts size variant. With the Fronius Symo hybrid inverter, it also provides a platform to transfer data to SolarWeb. And this was also our first hybrid inverter that we did produce. So using the technology from the Fronius Symo hybrid, we incorporated a lot of this technology into our new Gen 24 Plus hybrid inverter range. Now moving on to the thermal storage solution, which is the Ohmpilot. Okay, so the Ohmpilot allows for efficient usage of surplus energy. It allows for optimization of self-consumption, and it does this by dynamically regulating a heat source. Okay, so just some examples of what you can attach to a Ohmpilot. This would be infrared heating, towel heating, any ohmic load. So any load that is purely ohmic. So you cannot install a load and connect it to the Ohmpilot if it has some inductance in. Okay, so a classic example of an Ohmpilot would be to attach it to a heating rod in a boiler or a geyser, and any excess PV energy that you do get throughout the day. It could be 50 watts of excess energy, or it could be 2 kilowatts worth of excess energy. You will just take that excess energy and send it immediately to your heating rod in order to heat up your water. Okay. So with the Ohmpilot, we can have a single phase output of 3 kilowatts, or we can have a 3-phase output of 9 kilowatts max. Some classic examples of the most common usage of the Ohmpilot. This would be for underfloor heating, for infrared heating, as well as heating rods in a boiler. All of these heating sources are purely ohmic, and not a single one of them have any sort of inductance within them. A very basic overview of how the Ohmpilot works in a system. We have a Fronius inverter. It can be a snap inverter. It can be the Gen 24 Plus as well. We then have a Fronius smart meter in the system, and alongside we have also installed a Fronius Ohmpilot. Okay, so previously we were producing 1,500 watts of energy from the Fronius inverter. 1,000 watts was being drawn and sent to the load, whereas 500 watts was being sent to the grid. Okay, in some cases we can't even feed power to the grid, so now the inverter was actually throttling down to 1,000 watts. Okay, in order to prevent the inverter from throttling down too much throughout the day, we can install an Ohmpilot, which will now take that 500 watts, which was going to be sent to the grid if feeding limits were allowed, or which was actually going to be throttled down. We send that 500 watts to the Ohmpilot, and now we can actually increase the self-consumption rate of the installation. Okay, so the advantage of the Ohmpilot is that you can, dynamically change the output of the Ohmpilot. Okay, so it works with, it can work with 50 watts, it can work with any amount of excess energy throughout the day. Okay, as long as you do not exceed the maximum output power of the Ohmpilot. Okay, with the Ohmpilot, you can also install a temperature sensor. So it does have an input for a PT1000 temperature sensor. And this allows for a much better control of your system, because now you can actually set the temperature in your boiler to stay at a certain temperature. I'll now be launching a poll. So I'll really appreciate if everybody could answer this poll. How stable is your local grid supply? So we can either select stable, relatively stable, and then the last option is not stable. Okay, thanks for sharing your inputs. I'll now be closing the poll. Just to share the result of today's poll, how stable is your local grid supply? The majority of today's attendees said not stable. Okay, so if you're saying not stable, the best solution for you would be to, install such a system which allows for off-grid to be, running off-grid for the majority of the time. Whereas if you select relatively stable, then you can actually go with a hybrid inverter. That would be good. And if you do select stable, it would most likely mean that you basically just want to increase your self-consumption rate for your for your customers. Again, with Fronius, we can satisfy any one of these three grid supplies, okay, using the solutions we will be presenting in today's presentation. I'll now be handing over to my colleague David, who will continue with the rest of the presentation. David.
Okay, thank you so much, Mo, for the first part of the presentation. So I'll now be taking our attendees today through the second part of the presentation, where we'll be covering the Fronius Gen 24 to look at this inverter in a little bit more details. So let's get into it and look at the availabilities in terms of variants for the Gen 24 Plus inverter. So this inverter, the Gen 24 Plus, is uniquely versatile. And by this, we mean that we are offering this inverter in two variations. So we have one variant that is offering a single phase output. And then we have another variant that is offering a three-phase output. So the variant that is offering the single phase output, just like our regular snap inverter series, you are referring to this as the Primo Gen 24 Plus. And then you have the three-phase variant that is the Symo Gen 24 Plus. So the naming is similar to the existing snap inverter series. In terms of the power classes, the single phase units are available from 3 to 6 kilowatts, and the three-phase variant are available from 6 up to 10 kilowatts. Then you have the possibilities to have 2 MPPTs for each of the variants. That is, you can connect up to or have up to 2 MPPTs working with your solar installation, and then have one battery input for each of the variants. So when you look at the Gen 24, we are talking about a system that is going to offer green energy for the future. And we have quite a number of nice features in this inverter. So number one, we can talk about a reliable basic system, whereby you can have individual energy transition, also reduced energy costs, expansion possibilities, depending on how you want exactly to handle the energy that you're generating from your PV system. And then just like with the existing line of Fronius products, we are offering a very high quality product with superb support in the market. In terms of efficient energy management, we have in the Gen 24 energy flow management. In combination with the Fronius smart meter, we can do a lot of things when you're now looking at energy profiling in the Fronius Solar Web. So the Fronius smart meter becomes an integral part of such a system. So load management in essence means, like my colleague has explained, you could have a situation whereby you want to combine both battery storage as well as thermal storage or generation of hot water. And therefore, you could have started off with a system that only incorporated battery storage. But then you do realize that you have excess PV production such that you can integrate something like the Fronius Ohmpilot to be able to make stepless use of available excess energy for hot water generation, and thereby increasing your self-consumption or taking your self-consumption to the maximum. So when you're talking about self-consumption or maximizing your self-consumption, one of the very easy ways to do this is using your PV system to generate hot water for you. So in traditional setups, we have thermal heating systems that of course have their advantages and disadvantages. But when you have a PV installation, you can almost hit two birds with one stone. So you can generate electricity on one side, and also on the other hand, you can also generate hot water using the Fronius Ohmpilot. So this is going to significantly increase the self-consumption of that particular installation. And this is happening, of course, as explained before, by using surplus energy, and this is connected to a heating element in a boiler. And already, as explained, we would like to emphasize that the Ohmpilot can only be used for regulation or control of OHMIC loads, and these are heating elements mostly. So this offers very efficient energy storage via hot water when you incorporate the Fronius Ohmpilot into the Gen 24 system. Another important point to take home about the Fronius Gen 24 Plus is the fact that it's a battery inverter. So you can use this inverter with a battery, but also this inverter can also be operated without a battery system, and therefore working like a typical grid connected system. So when you talk about a battery connection, we have two battery types that have been qualified from two manufacturers for use with the Gen 24 Plus inverters. One of the manufacturers is the BYD battery. And for this one, we have two variants, which is the HVS and the HVM. So depending on how BYD wants to introduce this battery package into the market, especially the African market, we could have the HVS coming before the HBM or vice versa, depending on the kind of study they do in the market. So it's very easy when you are operating the Gen 24 Plus initially without a battery system to retrofit the battery later on. So this can also be something to consider depending on the budget that the customers have at the beginning. Maybe this battery is not enough to cover also the installation of the battery package when you're starting the installation. But if you want to retrofit the battery system, this can be done very, very easily using the BYD batteries. So of course, this goes without saying that once you integrate the BYD battery storage, you increase significantly your self-sufficiency as far as energy is concerned, because this means that you can also be able now to utilize stored PV power at night by discharging your batteries. So a normal or a typical grid-tied installation, of course, once the sun sets, that is the end of production for that day. But with the battery integrated, you have even longer periods to use your stored PV energy. So you can get a lot of power from the battery side. So with the Fronius Symo 10 or the 10 kilowatt three-phase unit, you can get maximum up to 9 kilowatts from the battery system to deliver in backup mode. So when you look at the Fronius Gen 24 Plus, it's also important to emphasize that we are also offering this inverter with something we call the dynamic peak manager. And this is assisting with production despite partial shading conditions. Because as you know, shading is one of the most detrimental aspects of a PV installation that can significantly reduce your PV outputs. But all Fronius inverters, the snap inverters, and now the Gen 24 inverters have the dynamic peak manager integrated. And the dynamic peak manager is basically allowing shadow management to ensure that even in partial shading conditions, the inverter continues to operate at the highest level possible. And this is happening by the PV inverter using the dynamic peak manager integrated in the MPPT's algorithm, being able to examine the entire IV curve of the array side from time to time. And this is happening with the Fronius inverters every 5 to 10 minutes. And therefore, this offers a better prospect or is a better proposition in terms of even reducing cost on the capex when you are considering your installation. So because the alternative, if you don't have a dynamic peak manager to manage shading condition, would be to install a system with optimizers. So the dynamic peak manager integrated in the Fronius inverters offers you a better proposition than use of optimizers. So optimizers increases risk of failures in the systems, but this is a topic that we can go into in another webinar. So also another important consideration of the Gen 24 inverters is the fact that these inverters, just like the other Fronius Snap inverter series, is actively cooled. So you get best performance despite of heat through this active cooling technology. So the biggest difference that you can note here is the fact that we have a cooling fan that is positioned at the front of the inverter. So you can see it from the front cover of the inverter. With a normal Snap inverter series, the cooling fans are normally on the sides of the inverter. So this is a very unique design with the Gen 24, because now this entire face here where the cooling fan is located is the heatsink, and the dissipation of heat is happening all around the inverter through the provided slots. So the use of active cooling technology, as you may know, if you compare this with passively cooled devices, is the fact that you significantly increase or optimize on the life of the electronics that are being used, because if you do not have active cooling technology included, there is possibility, a very high possibility, that at some point in time, you're going to have creation of hotspots in the inverter or the electronic device. And once you have these hotspots developing, you are going to significantly cut the lifespan of your product, because for every 10 degrees increase in the operating temperature of the electronics of a device, then you cut the lifespan of that device by almost half. By the use of the active cooling technology in the Fronius Gen 24 inverters, we are also guaranteeing you more yield for your systems. Especially, this is very ideal for the African market, where we have some regions with very high ambient temperatures. Some regions do get average 35 to 40 degrees ambient temperatures. So when you have these kind of situations, most inverters that are passively cooled will start to derate at some point, and some of them will actually derate at as low as 30 degrees ambient temperature. But with a Fronius inverter that is actively cooled, the derating behavior will happen much later on at almost 50 or 55 degrees ambient temperature. So that guarantees you a lot more yield. So when you have also an inverter that is actively cooled, it guarantees you that that inverter will be much lighter than a passively cooled inverter, because now the composition of the heat sink does not require to be as bulky as when the inverter does not have an active cooling concept in it. So this active cooling technology then guarantees you or gives you more flexibility and ease of installation of the Fronius Gen 24 inverter. So in terms of the storage solution, as I had mentioned before, the Gen 24 inverters have been tested for compatibility with the BYD battery box. And this is the premium version of the BYD battery box, the HVS or the HVM. So we will get into slightly more details of the BYD battery box, but just to give you some quick information is that this battery box premium from BYD is of course very secure, because it's utilizing lithium ion phosphate batteries. Then you can do the configuration of the battery in a modular fashion. So when you're talking about the HVS series, you can start with 2 up to 4 modules. So you can see this battery stack here, it has about 1, 2, 3, 4 modules. And then you get a maximum of about 10.2 kilowatt hours for the HVS series. When you look at the HVM, you can have 4 to 8 modules, and therefore it means you can get a maximum of 22.1 kilowatt hours per battery stack. So it's also, like I said before, retrofittable. You can start with the number of stacks or modules that are allowing or allowable by your budget at the beginning. And then later on, the BYD battery box is quite flexible, and you're able to add either modules or attach battery stacks to operate in parallel at a maximum of 3, as my colleague had earlier mentioned. So also, there's also a lot of ease in terms of installation, because the entire of this battery stack is ground mounted, and therefore you don't need to struggle with trying to position it in a wall, on a wall mount system. And also this also provides for very easy commissioning through a very nice wizard that is provided by BYD. So in terms of how the operation with the Gen 24 plus batteries can look like, we can look at several scenarios that incorporate or are emphasizing the multi-flow technology included in the Gen 24 inverters. In this particular setup, we can see an example of battery charging in backup mode. And also, we can also do charging when the battery is connected, or the Gen 24 inverter has its own array of PV connection. So in this particular example, this is an indication whereby you can retrofit the Gen 24 Plus inverter into an existing grid-tied installation. As we may know, up to now, most Fronius installations in Africa are for grid-tie applications, and therefore this means that there has not been use of battery storage with the Fronius systems mostly. But with the study of the energy flow in SolarWeb, you can now make a decision at a later point in time, depending on excesses of energy available. And this is also facilitated by the use of the Fronius smart meter. You can also decide to AC couple now the Gen 24 plus inverter with battery storage into an existing grid-tied installation, and therefore make use of the BYD battery box as I earlier indicated. Another case would be whereby you have an installation that is integrating also PV array connection to the Fronius Gen 24 inverter, and also that is also coupled to an existing installation with the Fronius Snap inverter series. In this particular example, we are looking at the possibility whereby also you can charge your batteries that are connected to the BYD Fronius Gen 24 inverter using energy from the grid. So there are some instances whereby the time of use tariffs, depending on the grid operator, are quite favorable, especially maybe early morning hours from maybe 2 a.m. coming all the way to 5 a.m. So some users might decide that if my battery state of charge is below a certain threshold, I can use my grid supply, and also depending on the time of the year, the season, whereby you realize maybe you're going to have an overcast condition for the next 1 or 2 weeks. Then in those kind of scenarios, you can decide that you can use the grid through the Gen 24 inverter to ensure that the batteries have a minimum state of charge always using grid power. Also, something that we can talk about regarding the Gen 24 inverters is the multi-flow technology. And multi-flow technology is happening in this sense that you can have the Gen 24 inverter plus inverter connected to a PV array. Then this PV array, with or without the battery, as I mentioned earlier, the Gen 24 can also operate purely like a grid-tied inverter. So the conversion is happening from the DC to the AC side, and therefore the Gen 24 is synchronizing to an existing grid and being able to feed that array power or the module's power directly to your loads for consumption. Also, if you are allowed to sell PV power into the grid, then you can export the balance of what the production is giving you minus what the load is consuming at that particular moment, and then the balance of that is exported to the grid. In most cases in Africa, we are not allowed to sell PV power into the grid, and therefore using the Fronius smart meter, we do what we call feed-in limitation, whereby we can say we are feeding only zero power into the grid, and that is enabled by the Fronius smart meter. So also, if you integrate the BYD battery storage, you can have a situation whereby using multi-flow technology, the solar system is delivering DC power to the inverter. Then the inverter is simultaneously feeding the loads as a primary concern for your installation. Then the surplus is going towards battery charging. And if you're in a scenario whereby you can still sell the excess power to the load, I mean to the grid, that is happening now, taking production minus battery charging as well as consumption, and then the balance is being sent to the grid. So in this kind of scenario in Africa, if you have the battery already incorporated, especially during the day, and the loads are consuming so much power, and you still have excess that can be seen mostly in SolarWeb, at this particular moment, you can decide to also retrofit the Ohmpilot to generate hot water using the excess PV energy. Another aspect of the multi-flow technology could be that during the day, you have the solar panels not generating as much energy as they should be generating, maybe due to overcast conditions, or maybe dust cover or something has happening with the strings of the array. And therefore, the energy stored in the batteries is able to supplement what the loads are consuming at that point. So you also have the possibility to have different flows of direction from the PV and the battery simultaneously to feed the loads. Also, as mentioned in the previous slide, you also have the possibility to recharge your batteries using grid power, depending on the kind of configuration you want to do in your system. Also, as another possibility with the multi-flow technology, if you have an existing PV array that is grid-tied or pure grid-tied installation, you can choose to retrofit the Gen 24 inverter in an AC coupled kind of configuration to be able to utilize all the excess PV energy to be stored in the battery system. And this is what we are now calling or referring to as the multi-flow technology integrated in the Fronius Gen 24 inverters. When you come to safety in case of grid outage, so the Gen 24 is able to give you inexpensive power backup. As I had mentioned before, the Gen 24 can give you what you call opportunity power using the PV point. And this PV point is working with or without a battery system. So all you need is PV connected to your inverter. And as long as the PV system is generating power, if you do encounter a grid outage, then the PV point is powered up, and therefore you have opportunity power through the PV point. We will be looking at the PV point in a bit more details in the next slide, but this is also to give you an indication that the Gen 24 offers you a very good flexibility in terms of you can start an installation with or without a battery and still be able to get inexpensive power backup from this system. So when you come to the PV point, what are the specific features of the PV point? So this is already integrated as a standard feature or function in the Fronius Gen 24 inverter. So, and the PV point for your information is only supplied if there is a grid outage. So ordinarily, the PV point would not be supplied with power. So if you have some loads that are connected to the PV point, it is advisable that you also incorporate an automatic transfer switch or a transfer switch of some kind to make sure that there is a smooth transfer between grid and solar power depending on power availability conditions. So once you have a grid outage and then the PV point is powered up, when the grid returns, then there is seamless transition also by using this transfer switch I've talked about. And therefore, the grid continues to power your loads, and then the PV point is disconnected by the inverter. In terms of the loads that you can connect to the PV point, the PV point is a maximum of 3 kilowatts in single phase. So also for the three-phase Gen 24 inverters, the maximum that you can get from the PV point is only 3 kilowatts in single phase. And the maximum in terms of inrush current that can be supported can constitute a power of up to 4.1 kilowatts for about 5 seconds. So this can be quite useful when you're starting things with the motors, maybe a fridge or a power tool that is connected to the PV point. So when you look at the PV point, it's actually very easy to use, and there is no additional installation necessary to be able to harness power from the PV point. However, the Gen 24 also offers us a very good possibility for full backup installation. And the Gen 24 Symo series is one of the very few inverters in the market that allow for three-phase backup kind of configurations. So in this kind of configuration, full backup, you can supply your entire household with backup power in case of a grid outage. However, what we should emphasize here is that the Gen 24 inverter does not operate like a UPS or the typical inverter chargers that we are familiar with most of the installers in the market. There is a time lag of about slightly less than 60 seconds when the Gen 24 is transferring from the grid to the battery system. And therefore, the poll that was launched by my colleague is also quite important for you to be able to know which battery system you should be using or which inverter system you should be using from time to time. So if you are in a stable grid area, the Gen 24 Plus, of course, is a very good inverter for you to use. However, if you are in an area where the grid keeps on failing from time to time, and you want automatic transfer of power when the grid fails, maybe the Gen 24 might not be the best option for you. And therefore, we can discuss about the AC coupled configurations with the Fronius and Victron kind of setup that might give you better transition times when there's a grid outage. So the Gen 24 basically is an inverter designed to increase the self-consumption of generated PV energy. So, or in terms of electric loads, like I've mentioned, this is possible for both three-phase and single-phase kind of loads. And this is also in terms of maximum energy consumption. As I have given you an indication of the multi-flow concept, you're able to have a scenario whereby you can have power or energy flowing in multiple directions. This can happen when you're consuming power or discharging and as well as charging the batteries at the same time, and therefore this multi-flow concept with Fronius. So now I would like to briefly introduce the BYD Battery Box Premium series. As I have mentioned, there are two variations or two variants of this series. So we have what we are referring to as the HVS, or the small variant, and as well as the HVM, or what we call the medium variant. So the key differences between those two battery types is that the HVS is a battery designed with high power but less capacity, and the HVM, on the other hand, is a battery designed with high capacity but less power. So in terms of LED status, you can get to know what the battery is doing right on site by looking at the LED status that is provided with the battery stack. And ease of installation, as I mentioned before, you can start with a few battery modules, and then you keep increasing your sizes to the required battery stacks, maybe a maximum of 8 for the HVM and a maximum of 5 for the HVS series. When you stack 3 of the 22.1 HVM stacks, then you can get maximum 66.3 kilowatt hours. So there are already a document available to show you the compatibility for parallel connection between the BYD and the Fronius Gen 24 inverters. So when you are considering the design of this kind of systems, always be sure to check the compatibility or the recommended configuration between BYD and the Fronius Gen 24 inverter. To give you more specific details, these batteries, of course, can also be installed outdoors. So you can see here that the IP protection class is quite high, IP55. And the communication between now the Gen 24 and the BYD battery box is happening through the Modbus RTU channel. In terms of the operating voltage, we have a nominal voltage for the HVS series of about 102 volts per module. And then for the HVM series, we are talking about 51.2 volts per module. So we can see where here we are talking about high or low capacity variations for these batteries. Once you have the full stack of batteries, whether the 5 modules or the 8 modules for the HVS or HVM respectively, then you can see here also the maximum operating voltage. So with regards to the BYD battery box, we are talking about a high voltage kind of configuration. So this is quite different from lead acid batteries, whereby the typical voltage would be 12, 24, or 48 configurations. So in terms of combination between Fronius and BYD batteries, as already indicated before, just to repeat this information, is the fact that the Fronius Symo hybrid is compatible with the BYD battery box HV series, and this is available from 6.4 to 11.5 kilowatt hours, and also available compatibility for the Symo hybrid with the BYD battery box premium HVM 8.3 to 22.1 kilowatt hours. So at this point in time, the HVS is still working in progress to have it fully compatible with the Symo hybrid inverter. In terms of the Gen 24 inverter compatibility, as already mentioned, we are talking about the compatibility with both HVM and HVS series. And this is for both the Primo Gen 24 as well as the Symo Gen 24 inverters. But like I mentioned before, it's always very, very important that you check the compatibility between the various battery series from BYD and the inverter or the Gen 24 inverter that you specifically want to utilize. As already mentioned, there is an independent test that was done for the Gen 24 inverters, and Fronius actually achieved very good results in this test. So from this link, you can download the entire test or document that was written after the test. And the combination between Fronius and BYD achieved the highest efficiency in the market so far. And in terms of the inverter efficiency from the Gen 24 side, we can achieve maximum on the higher side 97.3%. And then when you're talking about now the system performance in combination with the BYD battery box, we are talking about a very good efficiency of up to 94%. And this is for a system that was tested using a 10 kilowatt peak. So all the other inverters that are compatible with the BYD battery box came second Fronius in terms of energy efficiency for this kind of configuration. So this is also a point that is also very good to emphasize, that when you have a combination of Fronius and BYD, you're getting a configuration that is very thoroughly tested for compatibility with very high efficiency. Having talked about the Fronius Gen 24 inverters, let's now look at the AC coupling concept, or what we call the microgrid solution. As already mentioned, if you are living in an area that is lacking in grid stability, or where the grid keeps on failing from time to time, you might want to think about an AC coupled kind of configuration, and this allows you to go into off-grid operation for longer durations of time. So in this kind of setup, just to give you some very good and quick information, is the fact that we can talk about a DC coupled installation whereby we are utilizing an MPPT charger and a battery bank plus an inverter to supply panel or array power to the loads. So in this kind of configuration, we can see that there's quite a distance or quite a number of steps whereby this conversion of energy is happening. And therefore, this kind of system might not be the very best in terms of efficiency in the market. When you want to increase the efficiency of this kind of installation, then you talk about an AC coupled installation, whereby we introduce a PV inverter into this kind of setup, and therefore all the energy that is generated by the PV array, the DC power, is fed into the PV inverter. Then the PV inverter, because it has very high efficiency with the Snap inverter series from Fronius, you can achieve up to 98% efficiency. You are able to convert all that power that is coming from the solar panels during the day, and you're feeding the loads, and the balance or the surplus power is going through the Victron inverter charger, for instance, in this case, to be able to recharge your batteries. So when you talk about AC coupling, we are talking about the coupling that is happening on the AC bus bar of the Victron inverter charger output and the Fronius inverter AC out. So that is what we are referring to as the AC coupled system. But you can also, in this particular example, as you can see, have a situation whereby you are suffering from grid outages from time to time, and therefore this means that your grid is not very stable. And you can have this kind of AC coupled installation as a grid kind of setup with maximum self-consumption. So if you have a situation whereby your peak production from the PV side is matching your peak consumption on the load side, this kind of AC coupled installation makes a lot of sense. And also for systems, let's say larger than 10 kilowatt peak or 10 kilowatt AC, these are systems whereby you can start thinking about AC coupling. So this system can operate as an off-grid kind of installation and can also operate as a backup kind of installation. In addition, we can have for best efficiency as far as the battery is concerned, charging of the batteries is concerned, a DC AC coupled installation, whereby if, for instance, these batteries were to run out or to discharge fully at night, you have the possibility whereby the DC coupling, using the MPPT charge controller here, is able to recharge the batteries as soon as the sun shines on the panels in the following morning. And that allows the Victron inverter charger to recover. So once the inverter charger recovers, it forms the grid again, and the Fronius inverter is able to start and now starts channeling the converted DC power to AC for feeding your loads. So also the possibility to include a standby generator for maximum independence, especially if the grid is not available and you are in an off-grid kind of installation. You can have a small generator incorporated to ensure that your loads or your batteries never fully discharge to the point whereby the inverter charger from Victron is not able to restart. So in terms of the power flow in such kind of a system, just to give you this information, is that during the day, as I have mentioned, you could have a situation whereby the panels are generating maximum power, and therefore you have a bit of that is going to the loads for consumption, and then any surplus available is regulated by the Victron inverter charger by using frequency shifting to be able to recharge the batteries accordingly. On the other hand, you could have a situation whereby there is a bit of irradiation deficiency, or there's dust cover, or there's cloud cover, and then the Fronius inverter is not able to give you as much power as is required by the load at this particular moment. So what would happen is the balance of power that is required by the load at this particular moment in time would have to come from the Victron inverter charger through the batteries. So this is giving you also a lot of independence. But also it's important to understand what would happen in the case of a fully charged battery system. So in this particular example, we can see that the Fronius inverter is still generating nearly 100% of what is coming from the DC side on the solar panels. Most of that has been going to recharging the batteries, but a bit of that has been going to load consumption. If the batteries are fully charged, this configuration does not need a hardwire connection between the inverter charger and the Fronius inverter for regulation. So there will be frequency shifting that the Victron inverter charger is going to increase the frequency gradually up to a point whereby the output of the Fronius inverter will be nearly zero. So already as mentioned, if you are living in an off-grid area or you are in an area where the grid outage is too much, you can think about the AC coupled installation for systems above 10 kilowatt AC consumption as a solution for those kind of situations. All this information can be, of course, seen in Fronius SolarWeb. So SolarWeb offers you a lot of possibilities to visualize your system. Just to mention a few details here is that once you incorporate a smart meter in the system, you can see both consumption during the day and also at night. So we can see here at midnight what was the consumption pattern. And then just after production from the PV system started, we can also see the consumption of the loads during the day. So this kind of energy profile can also allow you to do what we call peak shaving or peak management to ensure that all the loads that are consuming heavily can be shifted during the day to during the day if possible, when the sun is producing a lot of power or energy through the solar panels. So of course, that does not stop here. Also, if you have the Ohmpilot integrated, you can see right from SolarWeb what is the average temperature of your water. But most importantly, also SolarWeb allows for quick troubleshooting of your systems by sending you state codes of the operation of the Fronius inverters. Also in SolarWeb, you are able to get into an area where we have a free design tool for strings that are connected to the Fronius inverter. In particular, we can talk about the design of a battery system. And the Gen 24 Plus as well as the Symo hybrid inverters are already fully integrated into the solar configurator. So when you come to the storage area, then you can specify whether you are designing a system with or without a storage. And the dimensioning of the battery size then is done based on an annual electricity consumption as well as the peak power of the PV system. So this solar configurator offers you a very cheap, and not actually very cheap, it's a free tool for you to design the PV array strings that are connected to the Fronius inverter. So you can see the recommendations also depending on the inverter ratio, and the inverter ratio is a consideration of the minimum and maximum DC power connected to the inverter in comparison to the maximum output of the inverter. So based on that, this free solar configurator is able to work out how many panels can be connected to one particular inverter and so forth. For further information regarding installation and commissioning of our systems, you can get a lot of information from the Fronius website when you go to the downloads section, where you download instructions, manual, and commissioning instructions. In terms of training, we also have scheduled events that you can go to the events section of the Fronius website and be able to see this information from there. And also, we offer a lot of tutorials and webinars like this one that are also posted into the Fronius YouTube channel. And from time to time, you can access this information to be able to use it at your own time. And for additional details, if you have very specific questions about Fronius products, you can talk to any of us. For Mohammed in South Africa, Cyprian in West Africa, and myself, David, in East Africa. And we are always very happy and eager to offer you support for any subject matter. So, and I think with that,